You guys enjoy Ken's talk? It's pretty funny. Unfortunately, I am not going to be making sick beats today. Um, Today, I'm just going to be delving deep on sort of just an annoyance I had while developing React Native DOM. It sort of inspired this talk, and it's about designing React Native modules, not necessarily the implementation detail, well, kind of implementation details, but higher picture, taking into account other platforms, because React Native is not just Android and iOS. Uh, get started, just to reiterate a bit. That's me. I'm a software engineer at Symantec, amateur music producer, bedroom, uh, basement, bedroom, whatever, one of those. I created React Native DOM, which, if you don't know, is an experimental, fully featured port of React Native's sort of native layer to the web, and it implements that same bridge. And if you want to follow me, I'm constantly just doing weird experiments with JavaScript, breaking things and following worst practices in really weird ways. So you can follow me there. But to get a little bit more specific onto what we're talking about today, I want everybody to just start thinking about, if you're a native module developer, like developing a custom native module for React Native, my goal today is really to just get you started thinking about supporting platforms or writing your code in a way that will best facilitate other platforms in your code. And this even extends, really the ultimate goal is that it should facilitate platforms that don't even exist yet. If you can think of your code in that way, where it's just nothing is really platform specific. It's not specific to iOS. It's not specific to Android. That's like you put that sort of code in your app code, where the native modules, they're just providing some sort of functionality. And that should be sort of normalized and shared. But first, just to get started, just to get everybody acclimated, go through a quick refresher on how native modules are written in case you don't know. I actually don't know if that many people have the need to write their own custom native modules, especially if you're using something like Expo. But I'm going to have this example. I have native in quotes because this example will be showing how native modules are written in React Native DOM, and they're written in JavaScript. So it is kind of native, but not really. It's just on a different thread. And the little sort of contrived example we're going to do is a history module. So like web history in the browser history stack. We want to expose that to React Native, and we define a history module, give it a name, and this will, ignoring sort of the plumbing needed to actually get this over the bridge. This is the rough boilerplate for setting up a native module. And then we initialize it, where we create the history stack just from like the history module on NPM using that. And then in JavaScript, we reference the native modules export from React Native, and history should just be there. And that's how we get it. And then sort of getting more boilerplate, and this is the code that you would end up running against in your React Native code when you import this history module, just be that history object. So let's start adding methods to it. We add a method push, and the $sign is React Native's way, or React Native DOM's way of knowing that this method should be exported to the sort of React Native JS side. And once we have that, we can add that push method to the native module on the JS thread side. And then we can do the same for go back. And this is all really, really simple. And in reality, doing this for Android or iOS is actually very similar. it's just a little bit scary because, you know, it's Objective-C or Java, and we're all web developers, or at least I am, and that's scary, not doing something in JavaScript. But it is this straightforward, and there are some issues though, because this isn't like really the whole picture. Like, yeah, we've implemented it for React Native DOM here, but the question is like, we need to think about platform specificity. And sort of the first question you might ask, and sort of the first mechanism you use for cross-platform code and sort of separating that is with the file name. We could call it history, just JS, nothing special, but well, if it's a DOM-specific module, like, do we add the DOM.js? There's also this .native, which represents just React Native in general, or something else entirely. And what we need to know then is sort of like, how does Metro, which is React Native's bundler, like pick which file to choose from based off of the platform? And it's a priority-based selection. You start with sort of platform-specific code, and in my case, because it would be a DOM platform module, it'd be .dom.js, right? If I wanted it to be more generic, you could start with .native, and that resolves to any React Native platform. And you would think sort of, well, what's sort of the point in that? Like, that's everything. If it's a React Native module saying any React Native platform, that's anything from React Native. But to really differentiate that .native.js and .js, what if you have a module that you want to support just traditional web? And the traditional web will resolve the .js file, but then your React Native code will be resolved in that .native.js file. So you can have modules that even support more than just every platform on React Native, but even just normal web code, like normal React DOM code. Just a little side note, .web.js is a little weird. So it sort of, in reality, it will never be resolved by a Metro bundled project, because React Native Web, and which sort of represents this web platform, isn't bundled with Metro. So it's kind of a different world. So it's only available, or like will only be resolved in like specifically configured React Native web projects. And I see that sometimes it's sort of more equivalent to the .native, but for the web. But it's also React Native. It's strange, and I just felt like I should point that out. And yeah, that's important. Like .platform, that platform specific, having the highest priority, it's not included in the .native, like saying every React Native platform. .web is not included in that. So with that background, if we go back to our history module, like I sort of said, this is a DOM specific module, so let's call it history.dom.js. But the issue here is, well, what if I'm on a different platform? If I just left it at this, and this was the only file available, we'd get that dreaded, I'm sure you've encountered it, the like module doesn't exist in the haste module tree, something like that. I think the most common one is the accessibility info error message. You just get one of those. So, and again, this is sort of part of that mindset of supporting other platforms, even if they're not directly supported. So what we can do is add a history.native.js that just has stub code. It just doesn't do anything, but it won't error. It will get resolved, and your code won't fail in the onset. And it's sort of, if you really need that functionality, you can sort of go back to that native module and contribute a native module implementation. But it doesn't break immediately so you don't feel like you have to just raise your hands and be like, okay, I guess my app is not going to support this platform just because it fails to compile. And like, it's sort of up to you. Like, you can make it so that it actually does throw errors but gives a good error message, just to sort of inform people where to go or what needs to be done. Or in this case, just on module load, just throw a warning like that. And that will sort of get their attention, maybe convince some people to implement that module in your platform. And this is also cool, and the reason why I did .native and not just the .js is that we can have another override here, where this represents the just React DOM code. So this history module could be used in just your traditional React web apps, and you all just reference it from the same way, import history.js, or just history. But that's just file level sort of platform overrides and support. Let's go a level deeper with the React Native's platform module. Now, the APIs we have sort of available, it's really small. We have platform.os and platform.select. How many people have used either platform.os or platform.select? Yeah, it's pretty common. It's really the way, apart from file names, that you sort of split up or do platform-specific code. And fair warning, I'm going to be sort of making fun of this API. I'm not saying that you shouldn't use it altogether. Like, there are definitely some great times, but I think there are some foot guns with these APIs that might be worth it, just at least looking out for. So if we start with platform.os, this is how you import it if you haven't seen that. And this is just a contrived example, like sort of the most basic. We can compare, get that OS version, and compare it with a ternary. And the value here is just a string saying if it is iOS or is not. And this is actually one of the good ways of using platform.os, because it's exhaustive. It's an if-else sort of, it's iOS or everything else. So this is actually, this code is sort of inclusive to any other platform, because it is an exhaustive conditional. But then if we start like targeting more here and we do this code, now this isn't great, because I'm working on React Native DOM, I'm working on a React Native DOM project, and this code gets run against that platform, the value is going to end up being null, because we're only checking for iOS and Android. And this happens a lot in code out in the wild, trying to add support. This even happens in the React Native core code base a lot, though fair to them, they started the code a lot earlier and weren't necessarily like they needed to get a product out, or so they didn't really think about that. So the best way to do it is to make sure that you have an else. Again, it's an exhaustive, I'm going to say that word a lot, exhaustive conditional. If we were using reason, reason might yell at us if we weren't doing non-exhaustive stuff. And I mean, sort of going back to even that reason aspect, like if we bring it into a switch statement, that might look a little nicer, and most JS linting programs would yell at you if you didn't have a default. So like, even if you're doing just traditional if-else stuff, it's like, make sure you have that else. It's the equivalent of the default. Now, what about platform select? Now, so that's sort of similar to the switch statement. It's an easier way of writing it, right? And you put the key as the platform, and the value is the value that you get back. But then the question is, what do we do for this sort of exhaustiveness? I mean, we could get a little hacky with sort of the way JavaScript does coercion and do a little uh, or is other platform, but something that it's funny because I was actually complaining about it on Twitter and somebody said, "Oh, it already exists." You can actually provide uh, a default key to platform select, and part of me wants to build an ESLint thing that says if you're using platform select, make sure that you provide a default. But that's sort of when you're thinking about this stuff, making stuff exhaustive, things like these defaults, and they don't need to do anything, but it's just making sure that something unexpected doesn't happen because some of your code is returning null where you didn't expect it to, and thinking about stuff like that. And this is a little, I don't know, maybe a little controversial, but I actually think of using platform modules and like checking, oh, is the current platform iOS or is it Android, and doing specific stuff like that. I sort of compare it to like checking the user agent in the browser. It's not exactly the same. It's harder to manipulate the platform string in React Native, though it is possible. But the code is just not scalable. You're not thinking about things in the correct way. And I actually think React Native is a lot more like the DOM than a lot of people think. And we've learned a lot of stuff on the web and in the DOM with sort of feature detection and stuff like that. So like this is an example. This is from like the React Native safe area insets code. It's kind of a nightmare. It's the way to figure out how much space to go to add to the iPhone 10, and specifically iPhone 10 by checking the width and height of the screen and being like, oh, that's the correct width and height of an iPhone 10. It must be an iPhone 10. So then they set the same. Like, this is kind of absurd to me. And really, like, what you should be doing, again, sort of fair play to the people who built this. They were trying to build something that didn't require any sort of native linking. And this was kind of the only way they could do it. But I still think that, it's just find a way to communicate the actual insets to JavaScript. Like, you don't need to compare stuff like the dimensions of the screen. And for another example, this is actually in the React Native core code. This is the hot module from the hot module reloading client. And you see here, this is actually decent because it's an if-else. But really, it's sort of thinking about this. Why is this API different between Android and iOS? There's not really much of a reason. On iOS, you're just calling redbox dismiss, and on Android or else, you're calling the exceptions manager dismiss redbox, right? So it's when you're building these native modules, you sort of think about that, and like the sort of that boundary between JS and native, that's the most important part, that interface. Defining that interface well is sort of the key. And like, why can't it just be like this? If it's the else, it's like, why can't we just make the iOS implementation the same as just everything else? It should just be consistent. And then as a final example, this is part of the text input component. This is bad because if you notice, it's using else if Android or iOS, like DOM, just sort of out of the box, I can't implement the sort of native module because it will never be called. And so, and again, the two OS operations are very similar, but they have different APIs. So you're just creating complexity, and for seemingly no real reason. And this could all be just extremely simplified down to just like, let's just say the API on the UI manager is focus. And just, it's sort of up to the native platform to implement that interface. not a question of, oh, the JavaScript needs to manage which platform we're currently on and call the right API per the right platform. Just have a contract and implement against that. Treat the native module interface as a specification. Like the JavaScript just binds to that specification. It's not binding to a specific platform. And the job of the native platform is to implement that spec. And you can even sort of, to make it even easier for other platforms as they sort of come up to support your module, you can encourage that by like really defining that specification. It becomes a lot easier as a platform developer to support other modules when the behavior and sort of the native interface is like well defined. And this is just like the DOM. This is like, you know, the DOM has web IDLs in their specifications, and it's really up for each browser to implement on those interfaces. And what's sort of funny is I've been thinking about this for a while, and actually we can go back to history, our history module quickly. But this was history.dom.js. This doesn't really follow what I've been suggesting so far. So we can change it to history.native.js. Say like, okay, this isn't actually specifically for the DOM platform. This is just the interface that it just is run against. And here we're just being safe, checking, oh, does history exist? And does history have the required functions, just like you do feature detection in the DOM. And again, there are so many different ways you could do it. Like that was just no-opping if it doesn't exist. Or you can conditionally add the methods to your module so that in userland code, they can check the existence of the function before they call it, sort of like the DOM does. And you can sort of, instead of checking per what platform you're on, you're just checking, oh, does this module like have this function available? And it's sort of up to you to figure out how you want to implement it. I think there isn't a best way to do it. It's more that you just be consistent within your module and sort of tell the users what that's like. But what's kind of really exciting is this is on the React Native RFC GitHub page. It's part of the whole Fabric re-architecture that they're working on, that they've explained. And this is a small part of it that sort of makes a lot of what I've been talking about sort of built in to the platform. This is just, it's very early stage, like there's no implementation yet, but this is sort of what we can expect. And so this is actually defining how it's going to work is when we're binding modules, at least internally with them, they've been implementing their modules with flow types. And what Turbo Modules is going to do is actually generate native C++ code from those flow types, and then it's up to the platform to extend or implement those C++ classes. So they will be sort of strongly typed, and that interface does become a first-class aspect of the sort of bridge between the code. And I'm really excited to see where this is going to go in the future, and I'm excited to actually sort of really encourage people to build new platforms. I think we're sort of on the cusp of a platform revolution, and it will be worth making sure your code best facilitates them. Thanks.